Hi everyone, we're live with our next speaker, Gian-Luca Frei. He's actually going to give a talk around OWASP Application Gateway, which is not such a known project. So here we are talking about it, what it is, and how you can use it to secure your web apps. He's the initiator and leader of the OWASP Application Security Gateway project. Besides his open source contributions, he is a security engineer at Zilke. He has in-depth experience with systems with the highest security standards, such as e-banking portals, internet banking protocols. In addition to his professional engagements, Gian is also a research person. He keeps on doing the modern cryptographic protocol research. So I would let him speak more about what he has to say about OWASP Application Gateway. Over to you, Gian. The stage is all yours.
Okay. Hi, everyone. I'm Gian-Luca. Glad to be here. And also welcome from my side, all of you to this OWASP Developer Security Summit. Hope you had some good talks already. And it's also for me an exciting opportunity to present that project here. First time on a OWASP conference. So yeah, let's get directly started. So this talk is about the OWASP Application Gateway, which is basically a HTTP reverse proxy that helps you build secure applications because it solves for you a lot of security things like login and session management. But later we will see that in detail. Before that, maybe a few words about me. So I'm Gian-Luca. I'm based in Switzerland, and I work as a security engineer for Zilke. Now it's about 2 years, and in those 2 years, I worked on several different software development projects, mostly in the field of online banking, but also in a few others like health applications, also some IoT projects. And especially in one of these online banking projects, we had some challenges, like, of course, it's an online banking project, so security requirements are quite high. And yeah, we wondered how can we implement secure login and so on. We had a lot of challenges in this area. And in one of those projects, yeah, I had the idea to create a open source project that helps with that. And that's kind of the birth date of this idea of the OWASP Application Gateway. So from then on, this was a side project by me. And then also got quite a bit of attention. And now also some other cool developers are working on that. So yeah, that's it. Why this matters? I think that's the most important question for every talk. As a matter of fact, many organizations moved from monolithic systems to microservice-based architectures. And this has a lot of advantages, especially when it comes to maintainability and so on. And this trend is something that I see for small greenfield projects, but also in large enterprise environments. But in my opinion, microservices makes it quite harder to implement security properly. And still, that's not really a big topic. And there's not a lot of talk about security and microservices. Why microservices make security harder? That's because you have different components and all the different interfaces, the interaction between those components needs to be secured. So in the end, the attack surface is quite bigger, and there are more entries for attacker to try to get into the system. So compared to monolithic systems, there's just more things you need to worry about. And at the same time, security architecture is still often an afterthought in many organizations and teams. And this is really unfortunate, because if you start adding security later in the stage of software development, it just gets more complicated, because some things already exist, and it's sometimes hard to put that on top. It's most of the time just easier if you start with a secure architecture right from the beginning. So yeah, that kind of circumstances led me to try to make to design a new option to solve those challenges with the application gateway. So what is it? What the application gateway is, it's basically an HTTP reverse proxy that is placed between your clients, so browser or mobile clients, and your backend services. And the main benefit for you as a developer is that it implements a lot of best practices, like security, security headers and logging, and also request tracing. But I think the main thing it provides for you is that it covers all the login and session management functionality. This means you can use the gateway to integrate a EAM system like Azure Active Directory, Google, so login with Google or any other social login provider, or even your own EAM system, like for example, if you have a known Keycloak instance or an identity server also. So it helps you to integrate this with OpenID Connect. So you don't have to implement this login and session management logic on your front end or backend logic, and just have to implement some minimal functionality there. As I said, on top of that, it acts as a reverse proxy, so you can use it to route requests to specific microservices and so on. But it's not just built only for microservices. You can use the application gateway also in other environments. For example, if you have on-premise applications within one company, or simple monolithic systems. So one of the most central functionality of the application gateway is the session management. And that's why I want to show you a bit more in detail how that works. So when you log yourself in an application with the application gateway, for example, with login with Google, then the OWASP Application Gateway covers all that logic of OpenID Connect. But after authentication, the application gateway issues an encrypted session cookie that contains all the information and stores that on the web client. When the web client then attaches this cookie to each request, which a browser does, that's like the way web cookies work. It then gets this cookie with each request and validates it and extracts from it the user information. And if successful, it replaces this session cookie with a signed JOT token, and replaces all the cookie-based authentication with a new JOT token in a authorization bureau header. So this is really useful because it gives you the best of two different worlds. First world is on the front end. So like here, there you have a cookie-based authentication. That means that you need to do almost implement no logic here, because web browser automatically handles those cookies for you. But maybe more important from a security perspective, you get a proper session, you get a proper cookie-based session, and those cookies are also protected with the HTTP only flag and the secure flag, so they cannot be transmitted via insecure connections or even extracted from the JavaScript context, which makes this cookie-based authentication mechanism a bit more secure than, for example, if you store a JOT token directly in the JavaScript context. But on the backend, you don't want this cookie-based mechanism, because then in the backend, services are often stateless. You want that because it's much more easy to deploy stateless services, especially in modern cloud-native environments. So there, it's very easy to validate this JOT token, which is added by the OWASP Application Gateway, because you can simply validate, and in almost, or I would say in every framework or language, you find libraries to validate JOT tokens. So that's a very easy thing to do. And also, you don't need to cover any logic like session limits, is the user not locked out, things like that. You don't need to cover in your backend service, and in your front-end service also not. There you just have to redirect the user to a specific login page. The reason that this data in the cookie is actually encrypted is that it enables horizontal scaling between different instances of the application gateway. So if you have multiple instances, any of those instances can decrypt such a encrypted session cookie, and then with that you get an easy horizontal scaling. But of course, we also have implemented the local blacklists of invalidated session cookies to enable server-side logout. So this is about the session management part. Of course, a lot of this can be customized. For example, this, especially this part here on the backend, you can fully define how this JOT token should look like. And in the case that you don't want any JOT tokens at all, you can also use different mechanisms to transport the user principal between the application gateway and your backend service. So I quickly want to highlight those three design principles, but because it gives a very good overview on how we try to build this OWASP Application Gateway. The first principle, and in my opinion also clearly the most important one, is that we try to design everything secure by default. And this means two things. First, all the default settings are selected in such a way that they follow best practices, and helps you kind of design a system in a secure zero trust approach. Of course, if you want, you can always change settings, but the default settings are selected in a secure way. Second thing this means is that if we develop a new feature, for example, a new functionality, We give our best to design this feature in a way that is hard to misuse. And this can be quite tricky because at the end, everything can be misused in some way. But we try to avoid adding features, for example, that are very hard to use or that needs very special security considerations. If you want such a feature, you can easily extend the gateway with it. Second design principle is that the gateway itself is also has also a stateless architecture. This is especially important if you deploy it, for example, as an app service or as a Docker container on a Kubernetes cluster. Also because the gateway itself as a reverse proxy is kind of a central piece, and if it fails, your application will not be available. Its availability is, of course, very important. And I think the best way to solve this is with redundancy. For that, this stateless architecture also helps. But of course, also for performance, if you have multiple instances, you can process more requests. Third principle is that everything is configured in a central configuration file. So per instance, one configuration file. This means there's no like web interface where you can add, for example, where you can add routes, for example, or change settings in the gateway. This must all be done in this configuration file. Main advantage is that you can, for example, add this configuration file in a Git repository and then automatically deploy it via CI/CD pipeline. And this enables you to really have a proper way to manage its configuration. And also, if you want to check out what is the configuration, it's very easy. Just check out the central configuration file. So those are those three design principles that, in my opinion, are like the foundations how we try to design this gateway. If you want to use the gateway, there are two main models. First, you can run it out of the box. There's a binary or a Docker image. And then you just have to write your configuration file. And if you use a Docker container, mount it, and it will start up. But of course, every project, especially in larger environments, has some additional requirements. If you want to extend the gateway with your own functionality, this is very easy because the gateway itself is a Spring Boot application. In fact, it's based on the Java Spring Cloud Gateway. And so it's very easy to add it if you are already proficient with the Java Spring ecosystem. You can simply create a new project, a new Spring project, and then use this annotation, enable OWASP Application Gateway, and then you can add, for example, additional filters that are executed with each request or so. Yeah, but we will take a quick look at that later. But first I want to show you how the out-of-the-box version works in practice. For that, I have prepared a short test environment. It looks like that. There's a front-end and a back-end application hosted on Azure as a static as an Azure static file container and as an Azure app service. When you access that, you go to this instance of the application gateway, which is itself also hosted as an Azure app service in this example. But before we take a look at this URL here, I quickly want to show you the configuration file, because in my opinion, this really gives you the best impression how the application gateway works, or at least what you can do with it. So for that, I need to share my new window. It's here. So what you see here is this configuration file. It is a YAML file, so it's very easy to write as a developer. There are two parts which are especially important. First one is here, the routes. Here you can define an arbitrary number of different routes. In that case, you have a front end, an API, and some other routes here, which are used for just debugging. For example, you see here the API route. We have here a pattern, this API/wildcard. This means that all requests which begin with API will be redirected to this URL here. For the front end, we have the same, but here we have just a default of all requests. But because more specific requests get a precedence over less specific patterns, if you get, for example, API/users, it will get to this route here. There are also some additional settings, like if you want to allow anonymous calls or so. So this is the one, this is the first most important part of the configuration file. Second part is here, the login providers. And what the login providers actually mean is, here you can define the different ways a user can authenticate himself. So in that case, we have two main methods. We have a login with OpenID Connect. And that are the details of the OpenID Connect login. This is basically a login with Google. So to make that for your own application, you need to go to you need to register at Google a new login with Google, and then you get these values that you can place here in the configuration file. Furthermore, we have also a login with GitHub. GitHub also uses Auth too, but not OpenID Connect, so it's a bit different. This is why here we have a different type. And then furthermore, we have an additional OpenID Connect login with our own EOM system. Yeah. There are some more things that you can define. There are a lot of details, like, for example, how you want to transport the user principal to your backend system. We use a JOT token for that. Here are some details, but you can also leave that out. Those are also default values. So let's check out how this looks like in practice. For that, you need to go here to this website. But you see here is now a simple simple blocking applications, but right now we don't have any articles yet. So maybe let's write one. For that, I need to log myself in. Click here, and now I see different login methods. This is now still front-end logic. What those buttons are, those are basically just links. So if you click here on login with Google, you get redirected to a special URL called auth Google login. And this path basically tells the application gateway, please log the user in with the provider named Google from the configuration file. So let's do it. We will get redirected to Google. This is now an OpenID Connect login. You can select here my OWASP account. And because I'm already logged in at Google, get directly redirected without any password prompt. So now we're logged in and we could write a new article. What we have now on the front end is we have here now a cookie-based authentication, which you can check out directly in the developer console. But maybe you wonder how this looks like from the backend perspective. To test this, give you a special route. This is called echo. This is also defined in the configuration file, and of course something only for development purposes. This is basically a simple application that requests the HTTP request. So it reflects the request. What you can see now is that there's no cookie anymore, but rather we have here this authorization bearer header. And if we take a closer look at this token here, you can see that's a RSR signed JOT token, and it contains all the information as defined in the configuration file. So we have here a login. We see here now the subject name is Google and the ID of Google. Email is verified. This is my email, and here also we have the picture, my profile picture. So the content of this JOT token you can fully define in the configuration file, like which claims do you want and so on. So yeah, that's how it looked like. Also, you can see here we have a trace parent header. This enables this like a unique ID which is used for every log, and it's forwarded to the downstream request. So you can also lock this ID, and that way you can achieve a cross service log collaboration, which is very useful, especially for large projects. So we have a few more minutes. Quickly want to show you also how you can extend it when you don't want to use the out-of-the-box version directly. For that, you need to simply create a Java Spring Boot project and add this dependency here. And then in your Spring Boot application, you can use this annotation here, enable OWASP Application Gateway. Now it's already a instance like you would use, so now you can run it, and it will start up with the configuration file that you also need to define here. What I've done here in this example is added a stub login. So that's like a mock login provider, just to basically demonstrate how you can extend it. This kind of very simple login provider. If we run it, you see here also directly all the logs of the application gateway. Now I can switch back to my browser window. Now it's on localhost, of course, because and when I now try to make a login with this stub provider, see this is now kind of a mock authentication method. I can simply choose my own username and log myself in, and yeah, I'm logged in. And if we now go to this echo request, we still see now we have here a authentication token for the backend, and in that we see now the subject is John Doe and his email too. So that's how you can extend it. Okay. Let me go back to the slides and say a few closing words. Some words about the current state. It's still work in progress, but everything that you have seen is already implemented and stable. Only thing that we need to do before we can release a productive version is we need to add some more functionality around horizontal scaling. There are some things like server-side logout that needs to have state on the server side. And for that, we need some additional logic here. So, or maybe also about the project team. It's not a one-man show. Patrick Steger and my humble self, we lead the project together. But we also have some open source contributors that help us with the coding. At that place, I also want to highlight, we're always looking for input. So if you have any feedback about the architecture, things you think you are useful, or things you think that should be in such a gateway project, please don't hesitate to contact us. And of course, also if you would like to participate and help us with the coding, then please ping me or Patrick. I think it's a really cool opportunity to also get some experience with security architecture. So if you want to know more, please check out the GitHub page. Please also star it. Then you get informed if we create a new release. And also there's a lot of info on the OWASP website that you can check out. Yeah, that's it for the presentation.
Thank you so much, Gian, for joining us today. It was a pleasure to have you. And there are a couple of questions in the chat, so you can probably connect with them and ask them. Thank you so much, everyone. We'll be live with our next presentation soon. And if there is anything, you can just post it in the chat box. But before leaving, we would like to thank our sponsors. So Sneak is our platinum sponsor for the show. Thank you so much, everyone. We'll see you soon in the next broadcast. Thank you.